This video, we're going to take a look at cell stoichiometry. Now, cell stoichiometry connects the number of moles of electrons transferred and the amount of reactant used or product produced. So it's stoichiometry. For cell stoichiometry, we're going to be using half reactions. So one of the half reactions we're going to see is copper 2 plus 2 electrons makes copper solid. For doing these calculations, typically a half reaction is enough to be able to do the calculation. And so I think every example that I've seen uses half reactions. And what this tells you is 1 mole of copper ions and 2 moles of electrons makes 1 mole of copper. And so we can use the mole ratio between electrons and copper to calculate how much copper is plated out. But before we can get to that, we need to see the amount of chemical that is reacting. So the number of moles of electrons we need to be able to calculate. Well, before we start that, current, which is measured in amps, times time in seconds, will give you the charge in coulombs. And we're going to be needing that charge in coulombs to be able to calculate the moles of electrons. So this relationship can be found in your data booklet. It's a little sneaky where it's hidden in here, but you can see that in this chemistry notation, it's on page 2 in your data booklet, that Q is charge and it's measured in coulombs, and that time is measured in seconds. But if we looked at current is amps or coulombs per second. And now we don't get an equation for this in our data booklet, but what we can see is that there is a connection here where A equals coulombs times seconds. And A is current equals charge in coulombs times in second. And so this relationship is actually hidden in the units here. So if you ever gotten a test and you weren't sure, you can find that relationship printed here in your data booklet. We're going to be able to do that to be able to calculate the charge or the number of coulombs that are transferred when we know the current and the time. So our first question here is for question 1. And so the charge is equal to the current times the time, so that's 45 coulombs that is being transferred. In question 2 here, they've got the charge is 87.6 coulombs, the time is 22.5 seconds, and so if the current, if the charge equals current times time, then the current equals charge divided by time. And so we've got 87.6 coulombs divided by 22.5 seconds. And if we punch that into our calculator, we will get 3.89 amps are required to carry that out. And so we can rearrange this to find time, current, or the charge. One of the things to recognize is that time needs to be in seconds. So 60 seconds equals 1 minute, and that 60 minutes which is an hour, equals 3,600 seconds. And if we had a day, it's going to be 86,400 seconds equals 1 day. And you're going to need to be able to do the conversion between seconds and different amounts of time. Some of these reactions occur for long periods of time if they're plating out quite a bit. So that brings us to Faraday's law. And Faraday's law uses Faraday's constant. Faraday's constant is 9.65 times 10 to the 4 coulombs per mole of electrons. So we can find that number in our data booklet as well. It's in this miscellaneous set of facts. And so Faraday's constant makes the connection between charge and the number of moles of electrons. And so the number of moles of electrons equals current times time, because that's Q, divided by Faraday's constant. And this is where we're going to now get into interesting cell stoichiometry. Now I'm going to be able to use the number of moles of electrons to go from one kind of chemical to one amount to another. And that's where cell stoichiometry sits. And so we'll do a question or two related to this. So the number of moles of electrons equals current times time over Faraday's constant. And so for question 5, it says that the cell is operating for 35 minutes. So I'm going to make that into seconds. In 1 minute, I've got 60 seconds. So that's 2100 seconds. And it's got a current of 1.9 amps. So the number of moles of electrons is going to be current times time over Faraday's constant. So that's going to be equal to 1.9 amps times 2100 seconds divided by 9.65 times 10 to the 4 coulombs per mole of electrons. And I want to make sure I get my order of operations right for this. So the number of moles of electrons is going to be equal to 0.041 mole. I only have 2 sig digs here, so I should only have 2 sig digs in my answer. And question 6 here says a cell transfers 0.146 mole of electrons. So the number of moles of electrons is 0.146, and the current is 1.24 amps. And then it wants time. So if number of moles of electrons equals current times time over Faraday's constant, time equals the number of moles of electrons times Faraday's constant divided by current. And so it's going to be 0.146 mole times Faraday's constant, 9.65 times 10 to the 4 mole of, or coulomb per mole of electrons. And I'm going to put those all in brackets and divide by current, which is 1.24 amps. And I'll punch that into my calculator. And this is going to take 11,362 seconds. Well, it wants this in hours, so I need to convert that. So the time, if it's 11,362 seconds, I want to get rid of seconds and be left with hours. 1 hour is 3,600 seconds because there's 60 seconds in a minute, 60 minutes in an hour. So 60 times 60 is 3,600. So this is going to be 3.16 hours. I have 3 sig digs in these numbers, so I'm going to get 3 sig digs here. So we'll use that in the next video to be able to show you how cell stoichiometry connects the number of moles of electrons and the amount of chemical that is being electroplated or used up.